Hi everyone, welcome to Conf42 and logistics as well as in federal space. And the topic for my today's talk is observability as a platform contract and how can we implement it zero code instrumentation and enforce it through a CI/CD pipelines. We're going to dive into different problem statements, what exactly the problem statement we're trying to solve, what are the various solutions along the way, and how we have solved this in our organization, which can be helpful and useful for not only our organization, but various organizations and industries along the way. So, with that context, let's dive in. So, before we dive in, let's understand what's the state of the observability today, which means we have to understand what is the problem statement, what are we trying to solve, and what are the pain points in the industry and in various organizations today. So, as you see on the screen, majority of the state of the observability today lies between these four blocks. And to give you when we talk about observability, various organizations have purchased and licensed various different observability tools, starting from Datadog, New Relic, Prometheus, Grafana, and many others, many million other tooling, different variations of tooling along the way. Which means every single tool would need a manual instrumentation, which implies if you have to find a certain log or a trace or a metric or any alerting you want to create, it should be coded somewhere in your solution or in a part of your application, which means it's a part of the manual instrumentation. And if you think from retrofitting this solution into existing organization or large enterprise organizations who have millions and millions of lines of code, it's very difficult task, a very daunting task, which means if a part of a code is not instrumented or you have not added a line of code which then generates a trace or generates a log, etc., it's a very inconsistent coverage. So only those parts which where instrumentation has been added would get a coverage. Everything else becomes a blind spot, which results into a very reactive debugging. When the fire comes or an incident comes, you become a very reactive way of looking at things, which means, say, if your instrumentation was already coded, some part of it is coded and some part is not. So if the issue comes in a very different part of your stack where it was not covered, it becomes a reactive approach of, hey, let's go fix this. So it's a very reactive way of looking at things, which can add a lot of frustration and a lot of incomplete solution. And team silos is also a big one, which talks about how current teams, platform teams would tell or think from a mindset perspective, we do not understand the application code's context. We do not understand what part of the code should be covered and should not be covered. And from an application team's perspective, they may say it's a part of the team's responsibility. So that creates a very siloed approach towards how we look at observability. So overall, if you look at these four pillars, it becomes a very incomplete solution, as well as a very disturbing culture, as well as very disturbing and frustrating experience from platform perspective, from an application perspective, and from a business perspective, it becomes a very challenging when it comes to reactive debugging, which means it's a cost to the company. So various organizations, even the larger enterprise, the larger the enterprises, the bigger the problem, the bigger the scale of the problem becomes. So that is the core of the talk today. And this is the problem statement which exists not only one enterprise, but many enterprises, and how we're going to solve for this. So that's how we're going to solve it. So as we talked about the problem statement which exists in various organizations and enterprises, let's now dive into what does the new model look like. It's called platform contract. And the core idea behind this is how can the platform contract elevate our observability from an opt-in heroics to an explicit platform responsibility? How do we transform it into a guarantees which is provided to every service in exchange of the kind of following paved road, right? The approach for this is to make observability as a first-class platform rather than an afterthought bolted into the individual teams. So it doesn't mean if you have added a core observability as part of your stack or a part of your application, you would still get that observability as a platform contract, which then results into a standardized instrumentation patterns, results in a consistent signal collection across various services so that as a business, as an organization, you get visibility into all the services rather than just some opt-in services which had a thought of observability as a first-class citizen. You also have a measurable reliability requirements, which is meeting your SLOs and meeting your SLAs with your external customer. And then also there is a federated way of doing a compliance verification as well. So these are the platform contract which we're talking about as an observability first class platform, which would then result into all of these outcomes as well. So let's also now dive into what does it means when we talk about this platform contract in detail. So as we talked about the platform contract, let's now understand how does it tie together with the service layer and the contract layer guaranteed observability. So if you look at the diagram here, you would see four core rings where one is platform layer, another is service layer or an app layer, and the contract layer, and then the guaranteed observability. So if you look at the top two, platform layer as well as the service layer, they are tied together with the contract layer. And then if you look at the service side as an outcome of this model, a service which is an service or an application would get an observability as an outcome of this platform contract model. So in a nutshell, if you have to understand this, the core idea behind this is a service would get a comprehensive observability without writing a single line of instrumentation code to get observability in terms of the logs, the traces, the metrics, kind of database call visibility, and all the observability artifacts. And the platform would handle the collection of all of these observability metrics for you, right? And the contract layer would define the expectation in terms of what should be the core expectation in terms of whether it's SLA, SLO, how the platform should behave, how the service should behave, etc. The contract would define those expectation with respect to the observability in this case. And then to make sure we enforce this as a compliance, a CI/CD, which is continuous integration and continuous deployment, will become very handy for us to make sure it is observed, it is enforced, and it is compliant, so that it becomes a first-class citizen in every single time. And then we're going to dive into a little bit into zero code instrumentation architecture next. So let's see what does the zero code instrumentation architecture look like. So if we start looking into a zero code instrumentation architecture, there are three core pillars or core components of the zero code instrumentation architecture: automated instrumentation, runtime sidecars, and base container images. So let's talk about each one by one. So, what does automated instrumentation mean? It means we will have open telemetry agents and framework configurations inject telemetry across languages and protocols without code changes. As a developer or an application team or a platform team, you have to write zero line of code for this instrumentation to work. That's why it's called auto instrumentation. So there are various different frameworks, Java Spring Boot, or any other framework you're using as a language, whether it come from Java, .NET, or other languages. So these agent has multi-language support, and they can be injected and configured according to what is needed. So that's why it's automated in that way. You do not have to manually write any line of code for your observability stack to work. And sidecar pattern would basically capture network traffic. It would capture database query. It would capture message interaction. It would capture your web traffic and all the component. And if you look from a application standpoint, starting from a web layer to the middleware to a database query, you get a visibility for your stack end to end, not just web layer, not just middleware, not just database queries, but end to end. And then there is a way to correlate a web traffic to a database query to a middleware. And So you get an end-to-end visibility with these runtime sidecars, and then you can build a lot of alerting along the way in terms of those metrics, traces, as well as the logs. And from the platform layer, if you talk about base container images, you as a platform team would ship a pre-configured images which has baked in observability component, which ensures the consistent deployment. What does it mean? It means your base images, which are being used for deployment of the service or an application to the production systems, it would have observability baked in, which means we have enabled OpenTelemetry agents. We have enabled what ports would it listen to. We have configured what kind of metrics, traces, logs would be enabled, disabled based on that, so that as an application team, as soon as you create a PR and merge your PR and the pipeline runs and it gets that base image, your observability is already baked in to that system. So that's why it becomes a zero code instrumentation. It abstracts away all the information from the application teams. Then if you look at the diagram below, your application code goes in, instrumentation layer comes in terms of the base container images, and then that has already baked in information about your observability components. Observability backend gets executed, and then at the end of this infinity loop, this cycle, you can analyze and improve how do you want to now configure, and then you'd start getting the results as part of your stack, whether you have a tool called Datadog, New Relic, Grafana, or any other million other tooling available. You can start analyzing and improving those results as a part of this instrumentation architecture. As we talked about the zero code instrumentation framework, now the next question comes out: how do I support my application teams or my platform team? What kind of languages do I support? And how do I, hey, we are in AWS versus GCP versus Azure. How do we get this working? So, good news, it is available for multi language as well as multi cloud. And I understand the reality we live in. We live in a very heterogeneous environment, which definitely requires a strategic planning along the way. So that's why when I talked about OpenTelemetry agents, it has support for automatic instrumentation starting from Java, Python, Node, Go, .NET, and many more languages, including PHP and others as well. And when you talk about cloud agnostic solutioning, we have done a consistent deployment across AWS, Azure, GCP using portable containers and standardized collectors. So if you use Docker containers and any of those technologies behind the scenes, it can be deployed to EKS, AKS, GKS with a very cloud agnostic approach. And for our organization, we have successfully instrumented 200 plus services across three cloud with 99.2% and more coverage, which gives us a good confidence in terms of multi-language and the multi-cloud reality. So it becomes a very widespread solution, which all the organization can benefit from. As we talked about the multi-language and the multi-cloud support, it's also important to talk about the observability contracts and the first class artifacts it generates. So if you look at the diagram on the slide, the core component would be defining the contract definition. We defined the signal requirements, SLO specification, and the validation rule. And think this from a platform as well as from the service perspective. The idea here is we want to have a very low noise and high impact signals. So we want to understand what signal would define a service to be reliable up, as well as the code efficiency, or if the system is down, what would that be? And then from an SLO specification, it's a service level. At a service level, we need to define what kind of SLAs, SLOs we want to define, which means whether we want to have a 99.9% uptime, whether we want to define P95 latency. So all of those becomes a manifest and pipelines, which are basically version controlled agreement. So think of this as contract which sits alongside your manifest as well as pipeline, and they're very much version controlled agreements. And then as a result of this, contract would transform your vague reliability goal of, hey, my website or my service is slow versus fast into a measurable and enforced agreement that integrate directly into your deployment pipeline. Then you can go with the confidence and say, my website's P95 latency is zero point 0.3 millisecond, 0.1 millisecond, so on and so forth. So rather than this vague goal of being a fast and slow, you can pinpoint to that data with the artifact. So that's the core objective of these observability contracts. So as we talked about observability contracts, we should also start thinking about how should we enforce those through CI/CD. So think of contract enforcements similar to CI/CD enforcement for security protocol, if or a testing protocol, or say for example, if your repo has a testing framework and the test coverage is not above 75 to 80%, we fail the pipeline. So similarly, these observability contracts should also be enforced through CI/CD. So take a typical example of your source code. Your code is committed, it is pushed, the changes are pushed to the repo. The contract validation, which is the core component of this, where you would verify schema and the API contracts, the contracts get validated. You would also do instrumentation check to ensure the observability hook exists, the pre-baked in image exists, and then the pipeline moves forward. So the core element behind this is, if the contract is the validation fails, or a schema fails, or contract enforcement or contract validation fails in the pipeline, there should be a way to fail the pipeline similar to if the test coverage is not more than 75%, or if there is a core security vulnerability and then the pipeline fails similarly. So think from a mental model perspective, your contract enforcement through CI/CD similar to how a testing or a vulnerable bug would be enforced through the continuous integration, continuous deployment pipeline. As we talked about some of the enforcement through the CI/CD, the another objective or a question we would ask is, what is the data telling us? What kind of results have we seen with those changes in our organization? So the diagram on the slide right now talks about on the left hand side and the right hand side around before and the after of this. And then the first half talks about the manual and fragmented approach. And then and the right hand side talks about the automated and the unified approach. The numbers we have seen is from the SLO, which was at 23% before, and the mean time to respond was 45 minutes. Both of those numbers has significantly improved. I would say there is an 60 to 70% improvement on those numbers. And not only those numbers have improved, but we have also seen our failed deployment has gone to 12%, which was at a very high rate of 30 to 40% before. And then similarly, manual rollbacks are 78% less now, where we have to manually roll back anything, which means we have now higher confidence in terms of deploying our services because we have observability in place for those. So that observability gives us a good confidence of deploying with confidence, less failure rate, our time to respond for incident has improved significantly, and our SLO metrics have improved drastically, and our customers are much more happier with those results. So these are some of the results I wanted to share so that it gives perspective on what are the key metrics to look for when you think from a success metric or KPIs to define to your leadership in various organization, and then how, and it would apply to different organization in a different way, but there is a costing related to number of resources allocated to it, number of licensing allocated to it, and specifically if you can save developers time in terms of the failed deployment and rollbacks, that itself translate into $1 million every single year, depending on the different organizations and different enterprises. And the cost saving of that, as the enterprises becomes larger and larger, and exponential in that case as well. As we talked about some of the results in a brief way, so let's zoom a little bit around what does it mean from vague targets to the measurable agreements. So as we touch a little bit around being a slow website to a fast website, or to a slow service to a fast service, or somewhat available in terms of P95 or P99 response time, and then what is our mean time to respond to a specific service or incident. So the core idea behind the SLOs is from vague targets to measurable agreements for our customers, for our stakeholders, for engineers, for platform, to everyone in the organization, right? So when we talk about these numbers, so what we have achieved is 99.9% availability, which basically target encoded directly in the contracts. So 20 to 50 millisecond latency when it comes to P99 or P95 in terms of the time enforced for the latency SLO. When it comes to the error budgets, are in the range of 0.1%. And when it comes to the reduced MTTR, talking about 73% in terms of after the contract was implemented. So if you look from a very traditional versus a contract based approach, we're talking about manual SRO tracking, which means not only we have a wastage of time in terms of we don't have a way to measure it, but even measuring it manually wastes more time for the developers and the teams. We have a lack of automated SLO enforcement, 80% or more, which is, I think, for us, it was like 85% or plus incident lack SLO context in terms of DB layer, web layer, middleware layer, and how does it translate into incident, and how do we respond back to with a better context. So that's a traditional approach flaws. And when we talk about contract based, 100% of deployments are SLO correlated. To correlate issue takes 10 to 20 minutes. And to identify a root cause, it could be anywhere between 5 to 10 minutes. So that's a very much contract based numbers, which gives us a good confidence in terms of deployment, in terms of correlating issue, in terms of identifying root cause. So we take away the vagueness from the equation and convert that into a measurable agreement when we follow observability with the platform contracts. As we talked about some of the numbers in the previous slide, so let's start looking into how does the release automation integration would work? What kind of deployment strategies would be implemented when it pertains to contracted? The overall baseline is the following. So you have a baseline capture, which is you basically record your current SLI performance before deployment begins. Canary deployment is usually a good way to look at this, because the core idea behind Canary deployment is you route a very small percentage of your traffic to a new version. So let's say, for example, if a service teams comes back with a new version, you deploy in a Canary deployment fashion. You start from 5% of your traffic split, or it can be 1%, 2%, depending on what the organization is comfortable with or the teams are comfortable with. Let's say, for an example, you start with a 5% split. And then based on that 5% split, you can also an SLO evaluation. So compare your Canary metrics against your baseline or your production live traffic, which is 95% of your traffic, and burn rate policy. So based on those two metrics, you would be able to understand what my P95 latency is, my metrics look like, have we improved our SLO, have we not improved our SLO. So basically testing this feature in comparison with your SLO evaluation. And if your numbers look good, you promote and then increase the traffic to 50% and then 100%, which is full rollout, which is a successful release. And if it does not satisfy your SLO requirement or degrade your SLAs and SLO, you can roll back. And then only 5% of the traffic was exposed to it. You tested it and then refine. So that not only gives you confidence in your deployment, but it also tells you your SLOs and SLAs and how your website is performing. So it not only gives you a good way to look at your services, but also improves your SLOs, and you can make these real-time decisions based on these metrics. So not only you are taking away the vague nature of the reliability metrics, but it also taking away the vague nature of how you deploy with confidence. So that gives you a good baseline to deploy with confidence and to deploy with better SLOs as well. As we looked into the deployment patterns and the confidence with the SLO contracts in connection with canary deployment and how it helps in confidence of the deployment with respect to SLOs and SLAs. Let's also look into accelerated incident response. So a kind of a streamlined resolution before and after, right? So from a symptom to root, these unified workflows would use existing traces, existing metrics, which would help us in rapid identification of problematic changes. So as we talked about doing a canary releases of 5% or 10% or 1%, depending on your organization's comfort level, as the new data would start coming into this, so we would have a way to automatically correlate to a specific deployment through a version tag. Say a version 1 is deployed and version 2 comes in, and version 2 has 5% traffic split. As we connect these different versions, this degraded SLI would then get tied to that particular version tag. And then if you have to do a trace analysis, a trace, if you have to expand a little bit, is basically multiple span, collection of multiple span. So you drill into a specific span, it would show where was the web call, where was the middleware call, where was the database call, and not only where was the database call, it was exactly the the database query which ran. And based on advanced observability tools, you can also connect into what query ran for what second and whether that was indexed or not. I think Datadog and many other tools provide that kind of capabilities where you can actually enable the database monitoring, which then talks about, and it has a flame graph, it has a spam graph. You can replay many of those and have a lot of correlation along the way, which gives you a very accelerated incident response. I have personally been in many of the situation where we had an incident, and then I was able to pinpoint directly from timestamp perspective, from database query perspective, as well as from the web call perspective. So I was able to take a query, run it back to an application code, was able to tie together to what deployment tag was culprit for that incident, and then also going back to the application code to a GitHub in terms of what exactly was the application code which was responsible for that error. So giving you that level of visibility would accelerate the incident response tremendously. What used to take you 100% of the time would literally take you 10 or 15% of the time. So it's a huge saving in terms of the incident response. And not to mention, whenever the incident happens, 50 or 100 people joining the call and taking hours to resolve has a huge cost downside to it or potential to it as well. So it gives you that accelerated incident response in many ways. So it's a win-win situation when it comes to your deployment confidence as well as accelerated incident response as well. So as we talked about the accelerated incident response, it's very important to talk about the adoption pattern that worked for us and can work for various different organization and enterprises along the way. Core components or core pillars you would see is the pilot, expansion, and scale in different implementation phases. In the pilot phase, I would start with 2 or 3 servers, which should take roughly around somewhere between 4 to 6 weeks. And expansion would be 20 to 10 to 20 services, 2 to 3 months of time frame. And then as you start measuring the result of pilot, result of your expansion, you would have early adopters. You would have some teams which has done a little bit of exploring along the way, and you have done some experimentation along the way. You have some learnings along the way, what works for your organization and what does not work for your organization, and some constraints to work with in terms of security, adoption, different teams, different adoption practices, etc. And then that's the point when you take these learnings and then scale, which is an organization wide ongoing. And then start with gradual introduction, which is start with pilot services, expand and avoid any roadblocks. And then when we start to scale, you also want to start doing in engineering training. So start with educating teams on SLO through workshops, through different documentation, through embedded platform engineers. What worked for us was an organization-wide workshop. So we would engage 2 to 3 teams every workshop. Starting from a sign-up sheet, we would engage 2 or 3 different teams in a workshop, and then we would pick up their use cases the metrics they are interested in, the traces they are interested in, so that it becomes interesting enough rather than a generic training or generic talk. And it solves their use cases and problems and service level metrics, which keeps them engaged and involved in the process. And when one team starts seeing the results and problems being addressed, that's when the adoption becomes contagious and it starts scaling out very rapidly. So that was one of the lessons which we learned through the workshops. Keep it very pertaining to 2 or 3 teams, target specific problem statement for that service team, and let it expand from that point. Have early adopters, champions, and then start creating community along with a good documentation along the way. So I think gradual introduction and training with a specific use cases was the adoption pattern which works and can be very well implemented in many organizations and enterprises. As we touched a little bit around the adoption pattern which works, I wanted to share about the implementation across various industries I've been involved in, starting from financial services to retail as well as in logistics. In financial services, we have achieved 99.9% of traceability across 2.3 million daily transactions. In retail, we maintain 99.95% uptime during Black Friday with 12x normal traffic using error budget policies. An e-commerce platform used error budgets to balance the feature velocity with customer experience during peak shopping periods. So we're talking about 12x, 13x, 14x of the usual traffic into the retail and then e-commerce space as well. Even in the logistics and maritime, we instrumented 450 plus microservices with zero code changes, which reduced our deployment time by 40%. So these are various industries I've been part of. We've implemented this. So that's why it gives us a good confidence that the adoption pattern works and the results also come through. So these are some of the kind of the examples and some of the data I wanted to share for all of us as to use and learn from. So we talked about adoption pattern. We talked about some numbers and some of the things we have done. The $1 million question is, how does this blueprint work for our success, right? For platform observability. So this is, if you look at the diagram on the right hand side, these are some of the blueprint or kind of paved road we should look into, which would give you, so these core 5 points, right, which would give you the blueprint for the success in your organization and navigation through your organization for platform observability. Zero code instrumentation, right? Deployed zero code instrumentation with open telemetry agents and base images. Defining contracts, define your SLOs definition, your signal requirement, work with your application teams on what are the high signal, low noise signals, which are critical for the success, bread and butter of that service. CI/CD integration, have a validation gates, enforce those gates along the way. Production monitoring, have SLO tracking, have error budgets along the way, which will help to balance out and for the SLO tracking, whether we are on track or no. And continuous improvement. Continue to improve. Start small, iterate over it over and over again until you get to the final destination. So these are the kind of blueprint of the success, which would one by one, day by day, iteration by iteration, can be improved on. And then these are the core pillars which would help us to get to the final state of platform observability with zero code. So once we follow those blueprint, what is the end outcome we're looking at? So let's look at, if we enable this at organization-wide scale, what are we looking at? We're looking at a measurable reliability. We're looking at continuous improvement. We're looking at safe velocity. And we're also looking at the team autonomy. And if you start looking back to the problem statement we started with, was these 4 pillars in terms of, there's a team silos, there is not very difficult or easy way to deploy confidently with automated rollback. And then how do we make sure our manual instrumentation, where the insufficient coverage, etc., etc. So the laundry list of problems is a huge to tap into. 4 pillars of coverage, manual instrumentation, and then how do you deploy with confidence and team autonomy, and very fragmented solution overall. So this is what gives you that will enable the organization wide scale with 99.2% of service coverage, 73% of faster MTTR, from 45 minutes to 12 minutes for your incident or mean time to respond. Confidence of your deployment, 85% or more, which is SLO driven releases, would give you that confidence, which we talked about during the Canary releases and how we can deploy with confidence. And 40% or more faster delivery, which means you reduce the manual validation, you rely on SLOs, and you rely on their service level agreement. And then we can have a faster delivery along the way as well. And if you have questions around, I'm more than happy to discuss this, how to implement observability contracts in your organization as well. And with that, I would like to conclude my talk here at Conference 42 DevOps 2026. This is my LinkedIn link. I would also share that in the presentation as well. Happy to connect over the LinkedIn. Reach out if you have any questions or any implementation details, or would love to have a discussion around observability. I'm more than happy to connect, discuss, and share ideas and even help on the implementation side as well. So I will look forward for many other talks during the conference. I hope this was helpful. This was worthwhile your time. And I'm looking forward for many more conferences and other panelists to share ideas and thoughts along the way. So that was my talk at Conf42 DevOps 2026. Thank you so much. Have a wonderful rest of the conference.